about our logarithm laws to begin with, I want to first mention, before we actually get into the rules, how they change between exponential and log. So if you recall, last year, if we had a log base b of y equals x, or we can have x equals y, either way. Okay? That's an L. You don't like my L? What is that time of year? There we go. We can rewrite this in exponential form as b to the x equals y. These are interchangeable back and forth, right? But now we got to talk about the real log rules. If you recall, in the log world, if I have the log base b of xy, in the log world, when you're multiplying two things behind it, you are actually adding them. Log base b of x plus log base b of y. I agree. That's correct. Yep. All right, we have the log base b of x over y. So in the log world, when we're dividing, we're really subtracting. Log base b of x minus log base b of y. In the log world, if we have a coefficient in the front of base b of x, that coefficient is actually the exponent. So this is log base b of x to the a. Right? Our exponent is actually the coefficient. It can go back and forth. And the last one I wanted to remind you of, if we have the log base b of b, so your base and it's what it's of behind it, this equals 1. Those are our 4 laws that we want to follow. And last year we expanded the logs, we condensed our logs, and we simplified our logs. You remember all that? See, I told you, today is going to be super easy. So let's start with expanding the log. Remind you how that works. So here we go with example number 1. Expand. And that is going to be 1 through 6 on your worksheet. Right, Hunter? Okay. We're expanding the log. Let's say I have the log a to the third, b to the second. Let's start off easy. So first of all, we are multiplying two things together. To expand it, that means we have to add them. So we're going to change this to log a to the third plus log b to the second. Then our next step is to take any exponent, and this exponent has to go to the front. Same thing with this one, it goes to the front of that log. So we have 3 log a plus 2 log b. All right, let's do one a little bit harder. Yeah, thank you. Example number 2. Again, let's expand it. See what's hardest on here. Let's do the log base 3 of z square root x to the third. Yep, we're going to expand this. So what I recommend is, first of all, when you're expanding it and you got a square root, we can rewrite that square root as an exponent. We can cube it, but we're going to rewrite that square root as an exponent. What is the square root as an exponent? 1/2. Thank you. So this first goes to log base 3 of z x to the 1/2 all raised to the third. Now we're going to go ahead and distribute that cube to both things. Okay? So we're going to have log base 3 of z to the third x to the 3/2.
Now that's it, right?
No, we're not done yet. Now, those two things are multiplied together. So that means we have to separate them by adding them. So we're going to separate this and say the log base 3 of z to the third plus the log base 3 of x to the 3/2. Are we done yet? Oh, one more step. Nope. If the 3 was there, I would agree with you, but it's not. It's the exponent. Yep. And this right here is going to become our exponent, or our coefficient there. So our final step would be 3 log base 3 of z plus 3/2 log base 3 of x. Now, one of the other ways you can write this, so in this book, sometimes they write it this way. The second part could be plus 3 log base 3 of x, all divided by 2. Means exactly the same thing. Okay? Whether you move the 2 and put 3/2 in front, or you divide the whole thing by 2, it both means the same thing.
So realistically, you could put it like that.
Realistically, yes, you could put it like that.
A little bit more right.
A little bit.
Unless you gotta do it.
Okay. All right. So let's go to example number 3. Example number 3. We're going to do 7 through 12 now. We are going to condense the log. All right. So let's start off with, let's say I have 1/2 log base 2 of a minus 4 log base 2 of b. Let's just do that one first.
Now we're gonna expand this one, right?
We're condensing it now.
We turn it into like how the first one.
Correct. We're going opposite of what we just did.
Log 2 to the a with the 1/2 on top.
Correct. We're going to move this to the exponent. I agree.
So it'll be log 2 a 1/2
Uh-huh.
minus log 2 b to the 4th.
Good. I agree with that.
And then it'd be log, would it still be 2 or would it be 4?
Nope. The base stays the same.
So it'll be log 2,
Uh-huh.
a to 1/2, b to 4th, right?
Close. In the log world, when we subtract, we really do what? Divide. Thank you. So this is going to be a to the 1/2 on top divided by b to the 4th. Now, how else can I write a to the 1/2? Yeah. So we can write this as log base 2 of the square root of a over b to the 4th. Questions before I keep going? Parker, you got a question? No, you're good? You sure? Well, I want to make sure that, I want to help your grades right now. We only have about a month before the end of the marking period. I want to, help some of you, so we would need to make sure we're solid. Okay. All right, here's example number 4. Okay. Let's condense another one. Oops. Let's see. Are you guys ready? Let's go with 3 log base 2 of h plus 2 log base 2 of k minus 7 log base 2 of w. So very first thing we want to do is take all of those coefficients and move them where? To the exponent. I move that one there, move this one here, and I move this one here. So I have log base 2 of h to the third plus log base 2 of k squared minus log base 2 of w to the 7th. So now we can condense it all into one. We have log base 2. In the first two, we are adding, which really means we?
H to the 3, K to the 2, W to the 7.
Where does W to the 7 go? On the bottom, correct. Because we are subtracting, we're dividing. Okay, any questions? Okay, move to the next part. Okay. Hunter, are you ready? Okay. Example number 5, we're going to talk about the last 6, 13 through 18. On these, I want you to evaluate. And I'm going to tell you, you're evaluating the expression. And I'm going to put a little star here. Must show work. Those of you listening out there, we must show work. Okay. Yeah, no calculator in this section. So let's say I have log base 5 of 1 over 25. Because I know what we need to be able to do this for going forward, so we've got to practice it this way. Sorry, but we do. All right, so first thing we have to do is somehow we've got to get a base of 5 out of this 1 out of 25. So technically our first step is we can change log base 5 of 1 over 5 squared. Right? 25 is 5 squared. But in order to get that 5 squared to the top, what do I have to do to the exponent? Yeah, so I have log base 5 of 5 to the negative 2. Then that negative 2 exponent really goes to the front, and I have negative 2 log base 5 of 5. And what does log base 5 of 5 equal? 1. So this right here cancels, and my answer is negative 2. So let's try another one. Yeah. Example number 6. Evaluate. Show work. Let's do log. Base 2 of 128. We'll do an easy one. So, what is the idea? What is the base we want to get to for 128? 2 to the 6, correct. So this is log base 2 of 2 to the 6. Then that 6 is going to go out in front. So I have 6 log base 2 of 2. And this cancels. That equals 6. All right, I want to do one showing you the other way instead of following the rules, but using the exponential form of it. Talk about that. Huh? Yes. All right, evaluate. Let's say I have log base 8 of 2. Log base 8 of 2. Now, looking at this, you can't change 2 to a base of 8 very easily, right? So one similar to this, we set it equal to, we could say we set it equal to our x, so we can rewrite this. We can write this as the base of 8 to the x equals 2. Now we can make 8 into a base of 2, right? 8 is actually 2 to the third power times by the x that's already there, equals 2. Now that the bases are the same, we call this a one-to-one function. So then I can set 3x equals to my exponent on this 2 of 1. So then x equals 1/3, exactly. So last example and I'm done. One more just like that. Example number 8. Last one. Let's go with log base 27 of 9. So we're going to set this equal to x because you can't make 9 into a 27 very easily. It's a little bit tougher to do. Okay? So now I'm going to rewrite this as 27 to the x. The base of the log is always the base to our exponent, equals 9. What number do both of those have in common? 3. I agree. So 27 is 3 to the third power, and it has an x on it. And 9 is 3 to the second power. 9 is 3 squared. So now since the bases are the same, it's a one-to-one function, what can I do with my exponents? Set them equal to each other. Thank you. 3x equals 2. Divide both sides by 3, and x equals 2/3. Do we have questions? Again, this is all review. Every single problem you're going to see today you have done before. It is nothing new. Are we good? Okay. Let me get you your worksheet.